Hi everyone.
Hey,
Zhilei.
Hi Trey. Hi Megan.
Hi there, how are you?
okay, so let's see here. Megan, I don't have a bio for you.
Oh, I'm just here to help moderate with some of the QAs. So this will be
Oh.
Trey and Jilei's show.
Okay. So we're nearly up to the hour, and I know that some folks are going to be joining us as we go along, but just with some initial housekeeping, thank you everybody for participating. Thanks to our workshop facilitators today. It's nice that they're taking the time, and we certainly appreciate it. This is one of the couple of, I think it's the last one for today, but we have had a couple workshops. So for those who are joining, multiple workshops today, welcome back. And then for those who are joining us tomorrow, we will have the conference sessions kicking off on Hopin. So I've said this once. Forgive me if you've heard me say this once already, but check your emails. Make sure you have the invite to the platform for tomorrow, and that's from hopin.com. The one thing I'll mention is that Algorithmia is one of the sponsors. We're very grateful for them, and often the sponsors and participating companies have a virtual booth, which you'll see tomorrow, and they are giving away some prizes, some giveaways, some virtual swag, often gift cards. Make sure you click on those. It's actually surprising how many people forget to do that, and you have a really good chance at winning a couple of the different virtual prizes and giveaways there. So just a nice reminder as well. The other thing is, and before I get to the intros and hand it over, make sure you're asking questions. I know that everybody's on a different part of their journey, and we certainly found that out today. And it's nothing new. Everybody's on, a different part of their learning curve. So there's no silly questions, there's no stupid questions. The amount of value that you get from these workshops are directly proportional to your willingness to ask questions that are personal, that are that could potentially be of help to your projects. So not to worry if you're beginning or you're curious. There's no silly questions, no stupid questions. If you miss these workshops, we will send those to you afterwards. In some small cases, there's some speakers or there's some companies, their PR doesn't want us to record, edit, and send back. The few and far between. So for the most part, after the event, give us a week or two and we'll send over a nice package with some of the material, the videos, etc., and any additional links or resources that the workshop hosts provide for us for those. So with that being said, we will get started. And again, thank you so much for the folks at Algorithmia for running this one in particular. They will be discussing today for you accelerating public health research, why healthcare needs MLOps. And if you're familiar with Algorithmia, I think you would be at this point if you've attended any of our events. They are really, I guess, the forerunners, the folks that have been there since day one when we talk about MLOps. So it's always very interesting to see what Kenny says. It's always very interesting to see what the folks from Algorithmia have to say. So I'm very excited for this one in particular. And not to mention the speakers that we have. So they are, as you'll see, coming to us with a lot of experience. Dr. Zhilei Ma, forgive me if I've pronounced that incorrectly. He helps customers move from AI and ML development to deployment with almost 20 years of experience in cloud computing. Also with business strategy and machine learning, which he's experienced in. And he has managed strategic solutions for organizations worldwide, overseeing teams to help customers be successful with their digital strategy. He's fluent in German, fluent in Mandarin, Spanish, as well as English, and he's received his PhD from the University of Stuttgart. That's very impressive. I'm very jealous. I took a Mandarin class. It didn't go so well, but I'm still working on it. I would love to be quadrilingual like this. It's pretty impressive. Trey is also here joining with us. Trey has over 20 years of experience in data analytics and data science practices in leadership, as well as sales and delivery. Is primarily focused at the moment on implementation of analysis, design, development, enhancement, and testing of applications. His experience spans a lot of different verticals, including finance, oil and gas, medical, pharmaceutical, sports, energy, hospitality, retail, defense, even federal and state government, as well as various technology sectors. And he has earned an executive data science certificate via Johns Hopkins University and is currently pursuing his MicroMasters in statistics and data science through MIT. Wow, that is a lot. So again, more power to those who are willing to ask questions today, because certainly there's a lot of knowledge within this session, and I hope you guys enjoy. And lastly, we have Megan. And Megan, apologies I don't have the bio for you, but I understand you're here to help along and to assist with any questions that folks might have. Thank you for joining as well.
Certainly, of course. And thank you so much, everybody, for joining us as well. And again, just to reinforce, I'm here just to help handle any questions. Don't hesitate to ask through the chat. We will have time afterwards for some Q&A as well. If you don't feel comfortable posting it publicly for any questions, feel free to just send us a private message and we'll answer it as they come through. So thanks again, and I'll just pass it back to you, Trey and Zhilei. Thanks again for this session.
That's great. Thank you, Megan. And I'm just going to make Trey here. I've made you the host. I think you can pass on the host duties to Zhilei as well. And I think we're ready to get started here, folks. So thank you so much. I hope you enjoyed the session. I'll be around here, but if I don't see everybody, see you tomorrow, and I will pass the torch over to Trey.
And so I just passed it off to Zhilei. Zhilei, you're gonna
Yeah, let me share my screen. All right then. First of all, welcome again to join this workshop. So today we're going to talk about accelerating public health research. Why healthcare industry needs machine learning operations. So in terms of healthcare industry, right? So vaccines, are one of the greatest public health success stories in the history of human being. So this is a nice, statement that Merck, one of the leading healthcare provider, has basically made. I think this is especially true, given the current situation, and also, one of the things that we have learned in the last 18 months, right? So vaccines, are essential to protect us, to protect human being. So as a lot of industries, companies in the healthcare industry, Merck has also applied AI ML technologies to help them speed up the vaccine research and discovery. So, what are some of the challenges from Merck when they're trying to apply AI ML technologies? So the first one is time, right? So Merck has to process tens of millions of virtual compounds and to screen them very quickly, to identify them very quickly, and analyze them very quickly. So in some cases, really in milliseconds, right? So that requires really, very low latency compute power. The second one is cost. So they want to leverage AI ML technologies to reduce the risk in investment, with the low rate of vaccines that are going to make into the preclinical testing. And also a third challenge is, they have a limited, by hardware, and they want to basically leverage, the compute consumption really on demand, right? So based on the current analysis or discovery they have to run, so they can scale up and down on demand for their machine learning workloads. So the last one is, scale, as I mentioned before, right? So computation efforts that grow exponentially, especially, by compounds being added, by adding, several compounds that lead to an exponential factor of the computation power needed. So those are some of the key challenges, they were facing when trying to apply AI ML technologies. And actually they are not alone, right? So, basically, based on our observation across industries. So, for most of the companies, they are facing the 5 top challenges. First is, the machine learning, to train AI ML machine learning models is easy, right? So, but once the model is trained, and the model is tuned and tested. So most of the models are stuck in the lab. So it's really challenging for the data scientist team, for the machine learning engineers teams to get their models into production. So there are different reasons, right? So first of all, there are disconnected teams. So, the traditional software, DevOps team or IT ops team don't necessarily understand the specific requirements of, getting machine learning workloads into production. And there is also a technology mismatch, right? So sometimes you may run into that situation already, that you don't have the appropriate runtime environment to support your machine learning models or your inference codes. So your DevOps team may need to take your model, take your inference codes, and to rewrite them, right? To refactor them to make it runnable in your current production environments. And there is also a challenge with stakeholder buy-ins, right? So, first of all, how can you prove value to your business users to demonstrate that your machine learning model, that your AI model can really help them generate more business results? And second of all, how can you convince your risk management team, your security team, that your model is going to run in a very well-governed environment, right? So there are really, stakeholder buy-in challenges, across all different organizations. And lastly, hidden technical debt. If you have never heard about this term, there's a very well-written paper from Google published several years ago, talk about hidden technical debt. So if you look at the machine learning model that you have trained, that's only a very, very small piece of the big picture, right? So around the machine learning models, a lot of things needs to happen, right? So versioning, dependency management, runtime infrastructure, right? Auto scaling, orchestration, monitoring, logging, and so on. So with all those challenges, so that leads to actually inefficient machine learning lifecycle, right? So it's very difficult to get a machine learning model from the training and development phase into production. And once the model is in production, it's very difficult for a lot of organizations to manage the lifecycle in production, right? So, and also at the bottom, you see several numbers, according to the studies, made by Accenture and also by Algorithmia. So those, surveys confirmed also, the challenges that we have learned in our day-to-day, right? So how did Merck solve those challenges, right? So they have applied the solution, MLOps solution provided by Algorithmia. So the solution itself takes an integration first approach, which allows their researchers to use the integrated development environment of their choice. So let it be Jupyter Notebook, let it be other training environment they were using. They can continue using that without any technology lock-ins, without any changes. And also, the best-in-class tech stack, right? So Algorithmia platform leverage basically the most advanced technologies today available on the market. That includes Kubernetes, VMware, the different scheduling orchestration technologies, and also with patent pending technologies like allows you to run multiple algorithms, multiple machine learning workloads on a single GPU, helps really screen millions of virtual compounds quickly and cost efficiently, right? Think about it, GPU resources are very expensive. To have the capabilities to run multiple models on a single GPU, to have 100% GPU utilization, that drives down the cost very quickly, right? So another benefits, of them is, the MLOps solution enables the team to really iterate very quickly, right? So once the research team has fine-tuned the model, they can quickly publish the model into production so that their downstream applications can really benefit from the low latency and a very short iteration circle. And some of the quantified benefits, think about the images per hour they have to produce. So in the past, the processing capacity is very low, and today they are able to process 12,000 images per hour. So that's a 3 times increase than before. So it's a huge productivity increase and also huge reduction of time to market. Also, the machine learning infrastructure and operations will be automated and streamlined by the solution, by the platform itself. That simplifies the workflow and also really allows their researchers to focus on what matters most for them, right? So basically the research and development efforts to build vaccines. So their researchers don't have to put a Docker container together and figure out how can they deploy the Docker container, and every time when they iterate through their machine learning models. There's also an interview on the AI for Healthcare conference. So I put a link here. If you are interested to learn more about the Merck story, feel free to watch that. So now you may ask the question, who is actually Algorithmia? So we are the enterprise ML ops platform. And so we are the market leader according to key OEM reader for evaluating machine learning operations. There's also reports available. Feel free to Google for that. So the company has been founded in 2014, and since then, in the last 7 years, we have been providing MLOps solution for a lot of very large organizations to allow them to use our solution in their production environment, right? So on the right, you see some very well-known names in your industry like Merck, Genentech, IQVIA, but also across different industries. So we also have a free version available. Is called Algorithmia Teams. So feel free to go onto the website algorithmia.com. And so today on that platform, we have 135,000 users and a lot of models deployed. And we have supported really 3,900 plus different language and framework combinations. And by the way, this is no typo, right? So this is we have seen really things. So those are really some crazy numbers, some crazy language and frameworks combinations that we have seen, we have supported. So now let's see the platform, the solution in action. So my colleague Trey has prepared a demo for you. So the use case is to identify blood cells. I think this is very relevant for the healthcare industry. So he's going to show you how can you leverage the capability on the platform to help you quick get your models into production and also govern your models during the machine learning lifecycle.
Thanks, Zhilei. So let's go to the next slide. And I want to kind of just describe this use case. And so basically what this is a computer vision model that I've actually trained in Google Colab using some different technologies. And then we basically train the model, we import our data, and then we do some testing in Colab, and then we upload our the trained model into our platform and then run the inference. So this is just kind of an example of the kind of things that we use, or sorry, kind of things that we see where we have data scientists that come in and they say, okay, I've got this model, it's ready to go. What now? How do I make this production? How do I productionize this? And how do I serve this at scale? And so that's what we do. And so as I walk you through this, I'm going to point out some things like I'll show you the platform itself, and then I'll go into Colab and show you what I did, and then how we upload everything to Algorithmia directly from Colab. You can do this with Jupyter Notebook. I'm actually doing this in Colab because I'm using a Tesla GPU to do the training. Otherwise, it takes like 10 hours. This way, it takes like anywhere from an hour and a half. So I've already got that trained. I'll show you the process, show you how we can basically leverage external development or the tools that you're using now and push your models into Algorithmia. And then I'll show you how we do the inference on our part, and then how we can actually access that through an API. And so what I'll do is I'll simulate an application that's calling the API using a specific API key in the files that we want to process. And then the output will be what you see here on the right. You'll have labeled, these are basically slides that can come from a microscope of blood samples. And so we're plotting out white blood cells, red blood cells, platelets, then also the number you see there is the confidence level of what it is. And so I played around with this data set quite a bit, and it's pretty accurate, but I mean, you can see in the background, it'll miss some stuff. So that's gives you some more opportunity for training. If you want to basically retrain your model, you can go in there and add to your training data set with these, excuse me, these examples. So let's see, next slide. So this is kind of where we fit in. So I'm doing the training outside of Algorithmia, but I'm actually pushing the trained model into Algorithmia. And so the train.py, the Python code is running in Colab. It's basically like a Jupyter notebook using PyTorch, and we use RoboFlow for the training set. This is actually a public data set that you can actually play around with. It's basically free to use. And so once we get the model trained, we save it in a hosted data collection, which I'll cover here in a minute. And then from there, Algorithmia will then, we build the inference algorithm. And what we do is we'll containerize that and serve it up and handle all of the MLOps overhead, or the technical debt that Zhilei had mentioned earlier. So I think I'm going to go ahead and share my screen. Let me take a sip of tea real quick. And too many screens here. Share screen, desktop one, share. All righty. Excuse me, a little asthma today. So this is the landing page for when you first log into Algorithmia Enterprise. And so it's going to give you an overview of the algorithms that you've got, that you've been working on, list of all of the algorithms you had. And then actually, let me go into organizations here in a second. But what I wanted to also show you guys is what we're famous for. So basically, this is the same thing you'll see on algorithmia.com, but on an Algorithmia Enterprise, we actually let you customize this to your needs. And so basically, this is a model catalog that actually, it's a searchable catalog that you can basically find different algorithms to do different types of things that, and so we organize those and make them searchable so they're easy to find when you have a lot of these algorithms to do. So like Zhilei said, in our at algorithmia.com, we've got over 16,000 models hosted, and so we've got that all cataloged. Let me go back into the main page. So I showed you my algorithms. One of the things that Algorithmia Enterprise also allows or provides is the ability to subdivide your different groups. So if you've got like a finance and a sales and marketing, or research and development, different departments that need to be isolated, you can do that with this. So these are basically organizations are basically groups of algorithms and users that are basically, think of it as kind of a multi-tenant environment. API keys are how we handle security on all of our algorithms. And so you'll see in the algorithm that I'm going to show you here in a minute, I have this specific API key, so I can actually track who's consuming what based on the API key. So you can actually assign different keys to different excuse me, to different applications or different groups that are consuming this, and so that you can work with like bill back and things like that to ensure that that the load is shared as far as the support. The other thing I wanted to show you is, actually, let me go, I'm going to go into the algorithm that I wanted to show you. Oh, actually, sorry. I want to go into data sources. So we have what we call hosted data collections, which is actually hosted on the Algorithmia server or Algorithmia cluster. But we also can map to Amazon S3, Google Cloud Storage, and Azure Blob Storage. So you can store your data and your input data, your output, your models, either on our platform or S3, Google Cloud, or Azure Blob. For this example, I'm going to show you Google Cloud. I'm going to show you our hosted data collection. And this is basically broken down into we have this, this is for the Algorithmia SE organization. And so what I'm going to do, what I want to do is show you how I input the data. So basically, these are the image files that we're going to be reading. And so this is, I'm going to basically read the first 6 of these and then process that and identify those with the algorithm once we're done. But I want to show you, we've got input and then we got the configuration. And this is what I'm going to, the next thing I'm going to show you after I get out of here is I'm going to show you how we update this model file. So I write this model file directly from Google Colab using the Algorithmia client. Excuse me. And then, so I've got actually some different types of models that I'm using for different types of demos. But in this case, we're going to be using this one for the blood cell count, and then outputting into this folder, which you see is blank now. I cleared it out so we have a fresh start. And then what I want to do now is, before I go into the inference code, I want to show you how we did the training, and then how I uploaded the model file, and then actually did some testing in Google Colab before I actually did an inference in our serving environment. So let me move this, this Zoom window here, and I'm going to go into Colab. So this is actually a model. It's a CV model called YOLO V5. I know it sounds funny, but it's actually really effective. This actually came out last year, shortly after version 4. It's much smaller. These model files, with even like 1,000 epochs, are like they're like 14 megabytes each. Previous versions, you have like 150 to like up to a gigabyte. So it runs much faster as well. And so basically, since Google Colab will basically delete your session after a certain amount of time, I do a fresh pull every time I want to run this way. I pull from there from the Git repository for this project. And then I connect to my Google Drive, and so basically I can cache, or I can store different models based on different types of data sets or different trainings that I want to do. So I mapped the Google Drive to Colab here. From there, I install the dependencies from that repository, but I also add the Algorithmia client here. And then I do the, it runs the, excuse me, the installation for this image. And then so you go down here, and then it'll tell you setup's complete and using Torch on a Tesla GPU. And then, so I got different training data sets in here that we can use. In this case, I've got the blood cell classification data set. So this is training data that they're providing, and it's basically the image files and the labels. In one of the slides before, it showed you RoboFlow at the bottom. That's actually what I'm using for the training data. And again, they actually provide this data set and some other ones for free, basically. So once we get all that extracted, we tell it how many classes it's going to be. In this case, it's going to be 3. It's going to be platelets, a red blood cell, white blood cell, and then we define that in based on this file. Build the model configuration file. And I'm not going to get too deep into this because this is more of the kind of the development of the training of the model. What we'll want to focus on is the inference and the serving here in a second. If you guys want to learn more about this part, there's a tutorial that they have that actually walks you through how to do all this stuff. But if you guys want to see that, like, we can provide you the links to that. So once we got that done, excuse me, we're going to train the model. And this, I'm not going to run this right now because this takes about an hour in this case. So it's 500 epochs. And then it spits out a, excuse me, a model file in here. It's got to refresh it. It's probably in here, sorry. And so basically this is the file that I'm going to be using to move into Algorithmia. We also, in this case, I have the tensor board, so I can look at the metrics on this training data set that I've done. And then we run a sample detection. And then once we're done, or we're happy with what the results look like, what I do here is I import Algorithmia here. I instantiate the Algorithmia client using a API key that I created specifically for this, and then the API endpoint. And so this is where we're going to be putting it. So this link is directly into the hosted data collection. And then this local path is where we're grabbing the file from. And so at the end, we use the client to actually push the file in there. And that actually only takes a few seconds. And then at the end, I have this to keep the session alive. So once we have that moved over, we have this last.pt file moved over, we go into our platform. And actually I've got that page open. I'll just go the old-fashioned way. I'm going to go into the Algorithmia SE, excuse me, organization, and then I'm going to open the model. And so this is a landing page for our models. You can see we've got a sample of the output of what's going to happen here. And then we also have a source code, or sorry, a sample input. And so basically we're using a JSON string to define the source. And then this is basically one of the files in that, excuse me, in that hosted data collection. So it's going to read that file and then it spits it out. Once we run that, this will say null. In this case, we don't have any text output. It's just going to write the file. And then, so what I'm going to show you after I show you how we incorporate this into our platform, I'll show you, I've got a script that actually runs a series of these with different file names, and it'll spit out a bunch of different inferences. So you can do that. In this case, it's going to be just from a command line, but you can call it from a Java application, JavaScript, C#, Node.js, a PHP, like a web app, another Python-based algo, R, and several more. So you can actually call this from other algorithms or other applications. In this case, I'm just pulling it from, or going to be calling it from a command prompt. So the other thing I want to point out is that this is, we provide a kind of a template for documentation. I put this together so that it's, you have some semblance of what it's, what the inputs and the outputs should look like. And then actually, I'll show you settings here. So basically, this is hosted on our internal Git repository. You can actually use an external GitLab, GitHub repository that you want to, if you want to host it there. But in this case, it's our own hosted Git repository. And so basically, you can do Git clone, work on it locally, and then push it back. And then once that's done, or once you do that, it'll create a new build. And so every time you do a git push or a build in here, we'll have an immutable image of that build, which you can then publish or not publish, or do A/B testing in between what's actually published and what's available, or what you're working on. And then we have our versions listed here. The source code, we go into that. So this is actually the inference code, and this is that you may have seen detect.py in Google Colab. I've adapted that code to run on our platform. So basically what we do is we wrap it in a def apply and process inputs. And so in this case, what we're doing is we're getting the source, and we've defined the format. But so we get the source, and then we actually pass that on to the inference algorithm here. I've actually hard-coded the weights file, which is the PyTorch file that we generated, or that we uploaded into the hosted data collection. image sizes. These are all static here. We set our save directories, initialize logging, loading the model. We're not using a second stage classifier, so we just kind of, it's set to false. Setting our data loader. Then we run the inference, and basically it'll process the image and then plot the detections on each image. In this case, I'm going to be doing one image per run of this, but you can actually set this to do a loop on a folder or a number of images, or this will actually work on an MP4 video, and it'll do a detection on each object and follow it throughout the video. So doing the inference, applying the classifier, processing the detections. And then, so a lot of the stuff, like this print time on here, that's a lot of that's for logging, debugging. And so what we'll see here is it's going to run through this, and then it's actually going to output the file into the hosted data collection on Algorithmia. So it's going to create, it creates the file name, then stores it in that empty folder that I showed y'all before. And so this is a similar command from Google Colab, where we Google Colab, where we took the client file and did a put file into that repository location. These are some parsers that were actually added, that were part of the source code that I used. We added some other ones to actually just process the source input, and so basically we're creating a dictionary and then processing that as input. So we do have a default data value here, so that if you put in a blank string, it'll run that by default, so you don't get an error. So one of the other things that I should have mentioned before is, so I said that we zip all of this up, and we containerize and get it ready to serve, wrap it in an API. So you may be wondering about dependencies. And so we actually handle that. This actually goes into a requirements.txt in the root of this algo. And so we're loading our Algorithmia, excuse me, our Algorithmia client, all of the other dependencies that are needed for this inference. And so whenever this is built, whenever you do a git push or click on build up here at the top right, it'll create a immutable image with all this on there ready to serve and wrap it in an API, which you can call independently. So what I'm going to do now is I'm going to show you. This is just a little bit of code. I made it bigger. This is basically a curl statement that I'm going to a set of curl statements that I'm going to run from a command prompt. And what's going to happen is it's going to call the algorithm each time by the API using the API key that I created for this instance, and process the file that I'm telling it to run on each one of these. Excuse me, each one of these instances or lines. So I'm going to close this and go into a command prompt and run that. And so it should run for six instances. You'll see some more text pop up here. But what I want to show you is, go back into here. So it's running. It's almost done. So, but I want to show you that in this output, we've got these detections that we process, and it takes about a second per, but it's actually pulling it each time. If you do this with a bunch of images in one go, it can run faster. But in this case, this is simulating a bunch of different excuse me, a bunch of different requests from another application. And so I've actually generated all of these inferences here. So we've identified white blood cells, red blood cells, and some of these other ones that have platelets. And as you can see, these were just now written. So with that, let's stop for questions and then pass it back to Zhilei, or Dr. Zhilei.
Thank you, Trey. Is there any question for Trey before we move forward?
No questions yet.
Okay, Let's move on then. Share the screen. Okay, so Trey, thank you again for the great demo. So hopefully you can see that in the demo from Trey, so he was training his model in Colab using Jupyter, using PyTorch and RainbowFlow, as he mentioned. So you can use actually whatever, training environments, workbench, languages and frameworks of your choice, and you can deploy them through the Algorithmia enterprise platform and to get your model into production up and running. So there is a really no limitation on that. And also I received a question asking, hey, is Algorithmia and a training platform? And the answer is no, right? So just to help you understand where Algorithmia fits in, so think about your machine learning lifecycle, right? So first you collect your data, you do some ETL pipelines, and then you calculate, produce your features and get them stored in your feature store. Once the data are ready, then you start to work on to build your model, right? So you are thinking using TensorFlow, PyTorch, scikit-learn, or Keras, and so on, depends on your use case. And you made your choice to using one of the training systems available on the market, let it be H2O, Jupyter, SageMaker, or Vertex AI from Google. And once you get your model trained, hyper-tuned, and tested, validated, and you are confident now to get your model into production, this is when the Algorithmia enterprise platform jumps in and help you to automate all the deployment and operations and security process, right? So with all the features that you can see in the purple box. Then on the right side, you have your consumer applications. Let it be your research lab applications, your business applications in sales, marketing, production, logistics. So they can easily consume your ML service through the auto-generated RESTful API endpoints produced by the platform. So to make to summarize, so Algorithmia Enterprise Platform is an ML ops platform to help you automate and operationalize your machine learning life cycles in production, right? So deploy, operate, and secure. Now, a lot of our clients have used the Algorithmia Enterprise Platform to speed up their process of machine learning lifecycle and get their models fast into production to get fast to the point of a return of investment, right? So what actually gives them the speed that they want, right? So speed is a game of confidence. So how can you gain confidence to also provide confidence to your organization for models in production? So for that, you need governance, right? So think about, I would like to use the metaphor of driving a car, right? So you can drive a car, the car is like a model, right? So whatever car that you prefer, that could be whatever model that you are working on, depends on your use case. And why can you drive a car without thinking too much of the underlying infrastructure? Basically, how does the car work under the hood, right? Because that has been automated and tested, validated, and also what gives you actually the confidence to drive your car in a very high speed on a highway, right? Because there's a governance in place. So the car gonna give you alerts when he detects some anomalies and detects some drift during the driving, or maybe the pressure, in your tires, jobs, all those kind of things. And there is also a catalog, right? So that's basically the menu. Let it be online menu, online help, or printed manual. So you have a catalog of all the services that you can get from your car. If you need some help, you can go to the menu, go to the catalog. to find things that you are looking for, right? So I think this is, could be a metaphor, if you want to relate to the MLOps, why governance matters. So let's also look at, some numbers, what the experts say, right? So those numbers came from the 2021 Enterprise Trends in Machine Learning report. I posted a link here, so feel free to download the report. It's produced by Algorithmia. So we have interviewed hundreds of experts, executives in the machine learning space. And so the survey shows across industries, 67% of organizations must comply with multiple regulations, and only a very, very low number, 8%, don't need to comply with any regulations. I would say for the healthcare industry, the number is probably 100%, right? So basically, almost every healthcare organization must comply with certain kind of regulations and compliance and policies. And across industries, 56% of the organizations struggle with governance, auditability, and security issues. That's the number one MLOps challenge for them, right? So as you can see, without those issues being addressed, there's no confidence. Without confidence, there's no speed, right? So you cannot move fast to get models from your lab fast into production. That's not possible. So, if you think about, what are the 5 key capabilities that you would need for governance in MLOps? So those 5 things are what we believe the key governance capabilities. First, you need catalog, right? So catalog to document, organize, and search models and versions in production. So you may ask, hey, I heard about the words, registry. What's the difference between catalog and registry, right? So, you may, using registries, in the ML suites from one of the, big cloud vendors. So registry is basically more for training and development phase. So there you may have basically different kind of models. So the catalog is really focused on production. So only the models that are approved, tested, validated, and approved for production will be basically put into the model catalog. So you can also call it model serving catalog, right? So once your model is in production, all of a sudden you would have a different concerns than in training or development phase. So how does my model perform in real time? How could I get the transparency and insights about my model performance? How can I detect the model drift in case of data drift, concept drift, so that I can take immediate actions to mitigate any risk to my business, right? And reporting, right? So how can I, show back or charge back to my business units to explain to them, how their models, have been used in production, and how should I provide evidence to the auditing and compliance department to demonstrate, who has caught what and when, right? And those are all relevant, reporting capabilities you need to consider. Security, I think I don't have to explain that. So that's very common sense. How can I secure my models to make sure that only authenticated, authorized users or applications can access certain machine learning models. And lastly, auditability, right? So basically, if you have done the first 4 governance capabilities, you would have collected, enough capabilities and information to provide the appropriate auditability to meet compliance and regulation requirements. So next, I'm going to go through each of mine and to explain a little bit in details. What should be the key considerations and how did we actually solve those problems or those challenges at Algorithmia. So first, catalog, right? So what are the key considerations for model catalog? First, you need to have a serving inventory, and to be able to know how many models do I have in production across all organizations, especially if you are working at a large multinational or even global organizations. That would be already a huge step forward. So when we talk to large organizations, to our surprise, most of them don't know even how many models do they have globally, where are they, who are they, what are they, how have they been used. There is absolutely no data, no evidence about the model inventory. And also, once you get a catalog in place, you may want to provide a Google-like search experience to help your data scientists, machine learning engineers to quickly find models that they can learn from, they can reuse, and they can chain them together quickly to build a machine learning pipeline, and to help your IT ops team and governance security team to quickly find out what are the models that I have in production. And also you may want to provide a metadata about your model, right? So the language that they are using, framework they are using, how many API calls did they receive, how many versions actually are already did I already deployed, and documentation, right? So this is a very, very essential. Think about how can you help your data scientists, machine learning engineer teams to understand how should I use the model, or even your DevOps team, so who are in charge of their business applications, right? So how should I use this model? How should I embed this model in my business applications? What are the input data that I need to provide to the model? What are the output that I can expect? And how did you actually, data scientists, train the model? How did you build the model? What are the training data that you have used, so that I know the data distribution, so that I can track and monitor that in real time, right? So all those informations, whatever that would make sense and help your team to better understand and to manage the model, you can put that in a documentation. So there is also a very, very useful template from Google. It's called Google Model Card. And that gives you, actually lays out a very well designed structure, and also the items that you can provide as documentation to your model, right? So feel free to Google that. And also versioning, as I mentioned, right? So basically, hey, how many builds, how many versions have I deployed? And the version itself provides a history of your model lifecycle, and it also gives you the capability to run some sophisticated testing cases, right? So for example, think about A/B testing. So if you can deploy a model, with 2 different versions, and then run A/B testing, route the traffic, to model version 1, 90%, model version B, 10%. And the versioning gives you also the capability to build those kind of test cases. So benefits, I think, is clear: governance, promote reuse, increase productivity, builds a community, right? So everybody can come to the model catalog and to learn from each other, to find things that they can reuse. Of course, shorten time to market. So let me give you very quick demo. So I think Trey showed that very briefly to you. This is basically the model catalog. We call it algorithms. We use the term as an umbrella term for 2 things, right? So the first is your model plus inference code, as you all know, in typical machine learning environment. And the other is anything that is executable, right? So anything that you have written in one of the 9 programming languages that we support, and that is executable. It could be a helper function, utility function. You can deploy on the platform, and to make it as a microservice exposed through auto-generated RESTful API endpoint. And you have all the benefits, like versioning, cataloging, documentation, as you have for machine learning model. So that gives you actually a lot of capability to provide really a catalog of everything related to your machine learning practice in your catalog, right? So at the top you see some categories. You can customize them. The top 4 will be shown as card here, and the rest will be shown as links or labels. And the catalog provides really a Google-like search experience. So let's say, hey, today I'm working on some NLP, use cases. What kind of NLP model do I have already in production? You can click on that, right? So, or now I'm working on a credit card application use case. What are the models that I have already in production? So I found one credit card approval. Seems very relevant. So when I click on that, you will be able to see the profile of your model, right? So here you have an overview, you have some metadata, and also the task that you can define to help you facilitate the search, and also the platform are going to use the tags to auto-populate the model catalog, right? And you have here the documentation, as I mentioned. You can put a structure in place to help the user better understand how to use the model. There is also a discussion board, to allow users to help each other out. And all the builds are immutable, are available, so you can really, publish the build to a human readable version, and to build A/B testing champion challenger models. You can also build an event-driven workflow, right? So using Kafka or SQS or Azure Event Hub and so on. And there is also very useful error pages, right? So here you have the full stack trace of the error messages. So in case that there's an error for your model in production, you can quickly identify the root cause and fix that. Right? So this is basically a very brief overview of the model catalog and how can you use that, right? So the next is monitoring. So when you think about monitoring capabilities, you need to consider the following things, right? So do I have the capabilities to capture input-output data, right? So that's only the basics. And in addition to that, how can I capture operational performance in terms of a call duration, so that I can measure, especially if you are working on a use case which requires low latency execution time, right? So how can I capture the operational performance in terms of execution time, who has called what and when, and how can I define my use case dependent inference metrics? So, if you're working on machine learning models, you know that, the inference metrics are all different, depending on the use case, right? So how can I, feed these metrics that I'm able to collect and the data that I'm able to collect to the monitoring and analytics tools that I'm currently have available in my enterprise. So which requires actually a very flexible integration capability from the solution that you are looking at or you are building, right? So how can I control which algorithms, which model can emit metrics to those tools? So, especially think about, security and compliance. You may want to have those control capabilities to define that, right? So, the benefit I think is clear. So it gives you capability to detect the drift in real time. And also now you have the data available so that you can make data-driven decisions, right? So before, as we talked to some clients, they told us, hey, we don't have any data to decide whether we should retrain the model or not. What we do is, we have a gut feeling, right? So we just retrain our model every 2 weeks or 4 weeks, and to make sure that the model is still in good shape, right? So that's a bad practice. So reduce model risk in production. Of course, you have all the transparency, what the model has produced, what kind of input has the model received, and who has accessed the model and so on. So that gives you a lot of transparency. And also, capture once, use anywhere through the integration to the different tools. So the approach we are using at Algorithmia is the following, right? So for each algorithm session, you will be able to collect the two kinds of metrics, operational metrics and inference metrics. So operational metrics, several examples, timestamp, duration in milliseconds, for the execution, the owner of the algorithm, so the name, the version, and the request ID and so on, right? So for those metrics, you don't have to do nothing. They will be automatically captured and put on a message payload. The second kind of metric is so-called inference metrics. So there you can capture input, output, but also anything that would make sense for your use case, right? So you can capture credit risk score, for example, for the credit card approval application. You can capture supply demand imbalance, for some logistic or even for trading in financial industries, right? So all those metrics will be put on a message through a messaging system, for example, a Kafka pipeline. So on the other end of the Kafka pipeline, you can really consume the message, to meet your different requirements, right? So to meet compliance requirements or auditing requirements, you can put the metrics in a data storage, for example, S3 Glacier vault, so that nobody can really change those metrics, so that you can prove the metrics are original, nobody changed that. So for auditing purpose, right? And you can, feed the message to a data warehouse of your choice to do some advanced analytics and feed them to real-time monitoring, or, they are actually unlimited, opportunities, right? So let me show you very quickly an example how we do that in Algorithmia. So this is basically the inference code of the credit card application approval, right? So I'm using a serialized model that I have pre-trained and validated. It has been uploaded to the hosted data storage on the platform, but you can also store the serialized model file, in one of the three, big cloud storage or any other storage that you may have, locally available, on-prem available in your enterprise. So once I have loaded the serialized model, I'm able to, use the model to do some inference, right? So I'm, use the model to predict the risk score, and then use the risk score to calculate whether the credit card application should be approved or not. And this is where you define your model inference metrics, right? So to do that, you can use the command client.report insights. It's very simple. It's like a natural language. So you can put one or multiple inference metrics into the report insights. So for example, my credit card application department want to monitor the risk score and also the final decision. And my risk management team or security team want to monitor the number of features that the model received as inputs, so that they want to make sure that nobody hacked my model by increasing or decreasing the number of features. It's so-called adversarial attack in machine learning. And the data scientists want to monitor some of the input features and find out how are those input features correlate to the inference output, right? So, so as you can see, with a couple of lines of code, you can really define use case specific inference metrics to meet the different requirements from different stakeholders. So once that has been, yes, please. Is there a question?
Oh, sorry, continue.
Okay. So once those metrics has been defined, so on the other side of my display, I have a local Python client. So which is going to make a bunch of API calls to this credit card application model. So what you are seeing now is, for the demo purpose, I'm using Datadog, but as I mentioned before, you can use whatever monitoring tool that you have already in place, New Relic, Dynatrace, Splunk, and so on, right? So you will see here, metrics, as we defined before, are going to come in, right? So this is the risk score, approval rates, number of features, and the call duration of the inference model in milliseconds. And you can also correlate, the features with the decision making together in a diagram to help you visualize, what are the visual relationships. And you can also, do some anomaly detections to say, hey, how does the risk score change over time, right? Same thing for approval rates. You can do that too. And another benefits, typically also available in monitoring tool is you can define alerts, right? So let's see, for this application, I can see, if the risk score is bigger than 0.5%, I want the monitoring tool send a Slack message so that all the relevant stakeholders, will be informed. You can also trigger some, automated workflow for retraining or for replacing the model with a new, with a new champion. When everything is back to green, you can send another message, back to the Slack channel to inform everyone. Here you see some examples, right? So the risk score is going into the red area, a message has been sent, and when the risk score back to the green area, another message has been sent to Slack. So this was a quick demo of the monitoring capabilities, and so let's move on to reporting. So in terms of reporting, you may want to know who, what, and when, right? So who has called what and when, and also the duration, the resource, resource consumption, estimated cost, and so on. So that you can show back and charge back to your business organizations, or if you want to using Algorithmia Enterprise to allow your customers to bring their own model onto your platform, embed their models in your business applications. That's a definitive a benefit, so that you can show back and charge back to your clients how their models utilize the platform, right? So also provide data-driven governance in terms of audit trails, right? So who has called a what when and so on, and also create a transparency for risk management. So that your risk management team or security team knows, okay, we have the capability if we want to do some forensic research and also to do the real-time monitoring, be able to know and who is actually accessing my model and how are they being used, right? So now let me go into the demo. What do we do with advanced reporting? So we provide basically the so-called governance reporting on different levels. What you are looking at is the platform level, and here you can see the diagrams using different KPIs, right? So that you can monitor, you can track. And here at the bottom you see actually a detailed view. It's like think about your phone bill, right? So it's like the detailed view of your phone bill. So which algorithms has been called how many times, and how many errors there were, right? So this also gives you a quality indicator of your models and help you to improve your model quality in production. And what are the resource consumption, right? So usage in seconds, memory usage, storage usage, and you can also calculate the estimated cost. As you can see, the numbers are changing because this is a live system. And in terms of cost, right? So you can define your own unit cost based on your own business case or your TCO. So you can break down, the CPU, GPU unit cost, so that the estimated cost really reflect the situation at your organization, right? So this is the platform level. So only the platform admin would have access to those information. That's another governance, measure, security measure, so that not everyone can see. The second level is on the organization level, as Trey mentioned before, right? So there's a concept or feature called organization. And organization is basically a logical grouping of three things: algorithms, users, and hosted data. So you can also see on the organization level how this specific organization have used actually the platform, which algorithms, how many calls, and here, the same KPIs. And here you can also go down to an algorithms level, right? So to see, hey, for this specific algorithm, how the results are being used. And all those information can be either accessed through API. So the platform has a very rich platform API to gives you programmatic access to all the information on the platform. especially for your financial analyst, they love CSV, right? So you can also download CSV, so that they can embed the CSV or import the CSV to their spreadsheet for further analysis. So that's a quick demo of how do we implement reporting. Security, right? So this is a must-have, right? So secret store, for example, how can I use a secret store to manage the secrets of my models applications? So let it be API key and authentication files and API address, things like that, or tokens. And how should I provide API authentication? Using API keys, GWT tokens, and how can I enforce the SE Linux policy for the underlying operating systems, provide a single sign-on experience with the SAML integration, and how should I make sure that the solution I'm looking at or the solution I'm building is SOC compliant, right? So all those things, think about it if you have to build these solutions by your own, and all those different requirements needs to be considered and needs to be implemented by your own. So the platform has all those features already built in and proven by some of the largest enterprises in the world in their production environment, right? So that's a huge benefit. So lastly, auditability. So we believe that if you are doing the first four correctly, catalog, monitoring, reporting, security, and that gives you really a heads up compared to other organizations, right? So you have really data-driven capabilities to provide the auditability to meet all the compliance and regulation requirements. Now to sum it up, right? So Algorithmia is the enterprise MLOps platform, and you can see, hopefully we are able to also show you that. So once the model has been, you can integrate the platform with your training environment and go through all the deployment process, and with all the operations capabilities across the board, you have the governance and security capabilities basically all built in as a platform, right? So that's a huge benefit. And we can deploy it on premise or in different cloud environments, and we support also Kubernetes and so on to really leverage the investment in place. So this is what we do, and that's also our mission. Basically, our mission is to empower every organization and every one of you to achieve the full potential through the use of AI ML. So with that being said, I'm gonna hand it over back to Megan for some Q&A.
Awesome. Thank you so much for you both. That was a great session. Really do appreciate it. And we have plenty of time for questions. While we're waiting for them to come in, and again, don't hesitate to send them privately or just to everyone in the channel. And I have a few to get us going. First, Trey, thank you so much for sharing the blog post link, which I'm sharing in the chat right now that you referenced earlier. We're happy to send these links along as well. If you do want to receive this information or the deck itself, feel free to reach out to marketing@algorithmia.com. First question for you both is Algorithmia SaaS? Do you have an on-prem version?
Yeah, I think I can take that one. So yeah, we do offer different operation models, right? So we can provide the solution as a SaaS solution, hosted version. Basically, we host that solution for you, and we can also deploy it on-prem. And we can also deploy multi-cloud environments, right? So AWS, Azure, and GCP. So it's really flexible and can meet whatever you have in place to get you started.
Wonderful, appreciate it. Next one is, does Algorithmia provide support for GPU acceleration?
I take that.
Sure.
So short answer is yes. We actually handle the auto scaling of GPU nodes. The inference that I showed you before, that is actually utilizing a GPU node. So we basically host that on in that case, it was a Python 3.9 on a Tesla GPU. So yeah, we handle, or we support GPU acceleration. Additionally, we provide you with the ability to subdivide a GPU over multiple algorithms, so you don't have to have a dedicated GPU card for each algorithm that you're hosting. So you can actually scale up and down inside of that same GPU node or card.
Perfect. Appreciate it, Trey. Zhilei, this question will be to you, but Trey, feel free to chime in. You did outline, 5 government capabilities that anyone must keep in mind as they're looking to, build out their MLOps solution. In your opinion, what capability is the most important?
I think that's a very good question, right? So I think in terms of governance capabilities, I would say it's like let's take the metaphor as a car, right? So without any parts of the car, you will not able to drive the car, right? So let's say let's take out the wheels, let's take out the seats, or let's take out the engine, right? So
yeah,
I think they need to work hands in hands to make sure that your model in production is fully governed, secured, and so you can have the confidence to move fast with the operations of your machine learning life cycles.
Think of it like a table with 5 legs. It's not going to stand right if you take one out.
It's a great way to put it.
Yeah.
All right, so we have one question from RT. Forgive me if I pronounce your name incorrectly. Does Algorithmia handle feature stores for models?
Yeah, so one of our clients is Deloitte, right? So Deloitte Digital, that's one of the division of Deloitte. They have built basically a platform for customer experience, right? So it's called HUX, H-U-X. So feel free to Google that. There is also an interview available on YouTube. And they have basically selected 3 things for their internal team to use to build the HUX platform, leveraging machine learning models, AI models. Those are, first thing is the training environment. So they have selected H2O, so free advertisement for H2O, right? So, and for the feature store, they have selected Tekton. And for model serving platform or MLOps platform, they have selected Algorithmia. So, we integrate with, to answer your question, we integrate with feature store, Tekton and others to allow you to, retrieve features, for your models in production. And to support model inferencing in real time, and that's something also available on the platform. Yeah.
And you just to add to that, you'd basically install the like in Tekton's case, you install their dependency and then import their modules, and so you can actually interact with it, say just with Python, as you would any other data source.
Great, thank you so much. And on the subject of Deloitte, you spoke to the value of how MLOps is really integral for the healthcare industry and for public health research. Can you talk through some other industries or examples that you've seen MLOps really being successfully utilized?
Yes, either of us can take that. I can speak to defense and banking. So basically, before I came to Algorithmia, I worked for a large bank based in Texas, and it's a heavily regulated industry, and so a lot of the stuff like with security, like SE Linux, was one of the big things that the Fed has been pushing down on IT organizations. But under with governance and supporting things like certified the images to host your algorithms, things like private CAs, single sign-on, and those all fall under security. But there's also the auditability component where you need to have basically a paper trail of who's accessing what, because there are certain regulations where say like a banking agent can access a customer's customer's account data, when they call. But if somebody else in that, either in that department or even another group accesses that data, you need to be able to have the audit trail to say, okay, this person accesses this, and then also the ability to exclude groups that shouldn't have access. So you need to be able to control things like that. And then defense is they're even more security aware, to where they basically have everything locked behind a firewall that's basically everything's air gapped. So that's security, and then also auditability, and then monitoring, especially for things like when you're doing object detection, that comes into play in defense.
That makes a lot of sense. Zhilei, do you have anything else to add?
Yeah, I think AI ML is across industries, right? So one of our clients is Cemex, one of the largest manufacturing in the world for construction materials, right? So they are operating globally, right? So different geographic markets, and they are using machine learning models to predict the product price on different markets. And that's very, very mission critical for their business, because the construction material market is very fragile, I would say, right? So very sensitive. So once you basically disrupt the price, it's very hard for you to get back to the game, right? So that means their models needs to be as accurate as possible, and they have to iterate their models as much as needed, right? So that means they need basically a solution. Again, give them the confidence to move fast, and with all the capabilities, automated versioning, deployments, auto generated API endpoints, and also with the monitoring and auditing, reporting capabilities. Gives them the full confidence to say, hey, this is the platform that we should use for this mission critical use case of our business, right? So, I mean, think about all the other industries. I think about healthcare industries. We have pharmacy insurance, and we have also across industry different clients, even governments, right? So United Nations, and as Trey mentioned, U.S. Army, defense. So I think there's no industry today that can neglect actually the power of AI ML. Yeah.
Appreciate it.
Just lastly on that note, if any organizations that's dealing with GDPR regulations, governance and auditability is huge. So that's when you're dealing specifically with European nations, be it whatever industry that you're in. There's certain regulations you got to follow, and a lot of that is auditability and things like right to forget or right to be forgotten, so on and so forth. So you need to be able to have the insights into your data, and then also like auditability, traceability, and just be able to kind of govern it holistically.
Oh, that's incredibly important. Thank you. All right, so we do have a few more minutes. Looking through, if you have any other last minute questions, happy to answer it. I have one last question for you. Zhilei, you talked about this, but you both can answer. Can you talk through a little bit more about the value of working with multiple stakeholders like Algorithmia plus New Relic versus just trying to find a end-to-end solution? What are the differences, and what are the things that you need to keep in mind when you're coming to that decision?
That's a very, very good question, right? So first of all, if you Google AI ML landscape, you will find a huge map of all the solutions of the vendors available today, right? So, so what does that mean to us, right? So for me, it means there's no end-to-end solution today.
Right.
So just give the diversity of the landscape today, So there's no end-to-end solution. Second of all, in comparison to, so the AI ML space itself, even though that has, existed for, 30, 40 years already, is still very young, right? So, like 2 or 3 years ago, everybody would think, TensorFlow is the go-to framework for deep learning. Today, you have PyTorch, you have YOLO, RoboFlow, all those things that are really, in terms of ease of use, in terms of capabilities, are much, much powerful than, using TensorFlow. So what if, after 6 months, a year, 2 years, 3 years, there are new frameworks, new languages available. So, you may want to make sure that you are not locked down by those, pre-claimed end-to-end solution, right? So you may want to look for something that gives you the control back, gives you the flexibility to use whatever is, is up to date, whatever meets your use case requirements, your business requirements, and in that way you can stay really flexible, also being nimble, right? So if you want to make some change, you can be really, be ahead of your competitors.
Definitely. No, that's great. We do have another question coming through, but Trey, if you wanted to add anything to that, I wanted to make sure you had the floor as well.
Okay, so testing is normally done at the training level, or whenever you're training the model, then you test it. What we do, since we don't do the testing on the inference level, what we can do is we integrate with things like GitHub Actions or Jenkins, and we can do some automated types of workflows that can do testing for you, or that can orchestrate your testing. So that's how we handle that.
Yeah, I'm not sure. Can you still see my screen?
Yes, we can.
Okay. So, for the automated deployment, right? So, we integrate with, as Trey mentioned, with your DevOps tool chain, right? So GitHub, GitLab, Bitbucket, Jenkins, CI/CD, Azure DevOps, AWS DevOps, and so on. So we can really integrate it into your existing CI/CD pipeline. So, here, you are seeing some examples that we have pre-created, the automated, deployment process. Here, you would have the possibility, once the model has been deployed on the platform, you can use the, GitHub Actions or, Bitbucket, CI or GitLab pipeline, or, Azure DevOps pipeline to trigger automated validation and testing process, right? So before you really push the model into production, you may want to finally make sure that the deployment didn't break anything, the model still, works good, so that you can go through those, validation process, and finally, publish the model into production. All those, basically deployment in staging areas, validation and testing, and publish into production environments. So basically, commit the change, and all those steps can be automated through the CI/CD pipeline.
Wonderful. Really do appreciate it. So I know we are running up on time. So just a big thank you to everybody who joined this session, and a big thank you to Trey and Zhilei for such a great and engaging session as well. Don't hesitate and don't forget to swing by our booth tomorrow during the conference. We're going to be doing a raffle prize for a $100 Amazon gift card. So, and we'll also be offering some shorter demo videos that are just recorded. So feel free to swing by on your own time. And I do want to hand it back to the MLOps World team, just in case you had any last minute items that you wanted to discuss as well.
Yeah, no, that's great, guys.
Just a quick comment, feel free to reach out to us on LinkedIn if you have any questions, right? If you want to, discuss a certain topic, more deeper, and we are very happy to connect with you.
Great. Zhilei, Megan, and Trey, thank you so much. I really appreciate it. I appreciate you dedicating the time, and we hope to see you tomorrow.
Thank you, everyone.
Thanks,
Take care.
everybody.